All right, my friends, let's go through it. Part A, notice that both of the factors are linear, as in they're both degree 1 and they're both different. So this is just the old distinct linear factors case. So the form would be good old A over x plus 1 plus B over x minus 2. And then just to be clear, this was the distinct linear factors case. Okay, now let's look at part B. So for part B, x plus 1 is a distinct linear factor, but x minus 2 is a repeated linear factor simply because it's to the second power there. So the form would be a over x plus 1 plus b over x minus 2 plus c over x minus 2 quantity squared. Okay, and this was kind of a combo of distinct and repeated linear factors, but really the point was that kind of what to do with that part right there. So we'll go ahead and call this a repeated linear factors case. Okay, now part C is new. Now x squared plus 9 right here. If I could factor it, I would, and technically I can. It factors as x plus 3i times x minus 3i. But we really don't want to have, anything but integers in this stuff. And so because of the process that we'd have to use, so I hope that makes sense. So in that case, we'd actually need to leave x squared plus 9 as a quadratic factor. So now it's a matter of, well, what does that mean for your form? So first, let's talk about this x plus 1. So that's just good old-fashioned a over x plus 1. And then you're going to have a second fraction where x squared plus 9 is in the denominator. Now, I want to talk with you about kind of just the pattern that's happening here. So really quick, back to kind of this factor that you should be pretty comfortable with. You had a linear denominator, and then you have a constant on top, which is technically 0 degree. And when we're doing this in the middle of a calculus problem, it'll make a lot more sense when you're a calculus student. But what we're looking for is we're looking for the numerator to have a degree that's 1 less than the denominator. And so I'm saying that because for this fraction right here, the denominator has degree 2. So what we want to put on top is something that's degree 1. And so something that represents any possible degree 1 polynomial. So that's why you'll see that bx plus c on the top there. All right. And so what we were focusing on there is what to do with a quadratic factor. Okay, and so it's just a matter of knowing the form, okay? Now for part D, you have a linear factor, and then you have a repeated quadratic factor. So the form would be a constant, which is degree 0, over the degree 1 part, plus you'd have a generic linear over the quadratic, so degree 1 over degree 2. And then, since it was a repeated quadratic, you'd need to have x squared plus 9 quantity squared as a denominator, and then you'd have a generic linear on top of that. And so this one, just to be clear, the part that I was focusing on form-wise is what to do if you have a repeated quadratic factor. Okay, and this is not an extensive list. There are other situations you could be in, but I would say the most common situations you could be in would be like the first 3. So distinct linear, repeated linear, and then quadratic factors. Anyway, those are the most common ones. Anything else, you could always just kind of like try something, and if it works, great. And if it doesn't, by that time, you can kind of figure out how to adjust it to make it work. So. All right, my friends. So with that said, now let's do a full-blown problem where you're not just going to write the form, but you'll write the form and then you'll finish the problem out. Okay. So for example 3, let's see if you can find the partial fraction decomposition. So for short, I'm just going to say decompose for the rational function 1 over x times the quantity x squared plus 4. Good luck.